Hey everyone, as you can tell by the title of the ping board, we'll be discussing asymptotes. Finally, right? Because I'll be introducing this idea for the different graphs, and we are finally taking a look at it. So there are three different types of asymptotes, and I'll start with the first one, the vertical asymptote. So as all asymptotes go, it will be represented by a dashed line. So for the vertical asymptote, it will be a vertical straight line, and it's a generic x equals to k, where k is any real value. All right. So because it's x equals to k, we'll be looking at the x value. All right. So the next question is, when does a graph have a vertical asymptote? So the definition of vertical asymptote is that if we have y equals to fx, and that if x approaches a certain value k, y either approaches infinity or negative infinity. One more thing, if x is at k, fx is undefined. That means x cannot be k. Alright, which means one thing, if x cannot be k, your graph can never ever cross k. Alright, so which also means one thing, and it's very important, your graph must not cross the vertical asymptote or intersect the vertical asymptote. Alright, because if your graph does cross the vertical asymptote, it will imply that there is a value at x equals to k, when in fact it doesn't. Alright, so this is an important point. Alright, and one more thing is, because your graph cannot cross the vertical asymptote, but it can get very close, your graph must be very close. Let's say it's at negative infinity, or if it's at positive infinity, or on the right side or on the left side, it really depends. So it will be somewhere around here or somewhere around here. Alright, but the main idea is, if x approaches k, y approaches either negative infinity or infinity. So one example would be the logarithm graphs. Let's say your base is 10 log x. So at log x, well, obviously it'll be at x equals to 0, but let's say it's translated. So let's say we have it x minus k. I'll talk about translation when we talk about translation. All right, don't worry about it. So at your graph will look like something like this, right? It gets very close to the asymptote, but you'll never cross, and you'll just bolt all the way down to negative infinity, right? So whenever you have an asymptote, you must kind of not only draw the asymptote, but your graph must be very close to the asymptote. All right, so this is one example of your vertical asymptote. Your other graph will include your algebraic graphs, where you either have 1 over x minus 1 or k or mx plus c over a quadratic factor, let's say x minus 2, x plus 3. Alright, in this case, you know that x cannot be equals to 1 for 1 over x minus 1 because you cannot divide by 0. But as you get close to 1, it's 1 over a very small number, right? So it becomes a very big number. So it either approaches infinity or negative infinity. As such, you have an asymptote at x equals to 1. For the logarithms, x equals to k. Here will be x equals to 1. Here, it will be x, same idea, x equals to 2 or x equals to minus 3, alright, because your denominator cannot be 0 and you have the 2 factors, so either factor cannot be 0, which is x equals to 2 or x equals to minus 3. Alright, and your graph must not cross the vertical asymptote, but must get close to it. Alright, so that is vertical asymptote.